Today we are doing section 4.3. We are going to multiply monomials. So monomials means we have how many terms? One term. So we will be multiplying one term to one other term. To warm up, we're going to multiply or simplify these. They're all multiplication problems by that dot in the middle of the numbers. We also have exponents on these numbers. We have to follow our order of operations. By order of operations, what should we do first? Exponents. An exponent means we are multiplying the base, the big number, by itself however many times the exponent tells us to. So 2 to the third we could write out as 2 times 2 times 2. That's just 2 to the third. 3 2's multiplied together. And then there's a big times sign in between those. 2 to the fifth is going to be how many 2's? 5 of them. Okay, so this is what the exponent means. Repeated multiplication of that same number. Questions about what an exponent means? I still see some people treat an exponent like it's just a multiplication problem. So some people were still just doing like 2 times 5. That's not going to work for us. Okay, for 2 cubed, 2 times 2 times 2, what does that give us? 8 times 2 to the fifth is 32. Our last step is to multiply those together. Ellie? 256. Good. All right, on the next one. 3 squared would be 3 times 3. Okay, times 3 cubed is going to be 3 times 3 times 3. Okay, so we've got 3 times 3 is 9. 3 squared is 9 times 3 times 3 times 3 is 27. 9 times 27. 243. Do we have questions about how this is working? All right, so do we need to expand them or do we want to just talk through it? I think this one we might be able to just talk through. What is 3 squared going to give us? 9. What about 2 cubed? 8. Is this 3 going to change? Not right now. What is its exponent technically? A 1. Technically it has an exponent of 1, but that means that it just stays a 3. What about 2 squared? 4. All right, multiplication is commutative, so you can multiply in any order you want to. But we are going to take 9 times 8 times 3 times 4. Now, personally, how I like to do this is I do 9 times 8, which gives me 72 times, what's 3 times 4? 12. And then I would probably use a calculator to do that last step if I had one. What is it? 864. That seems about right. Okay, if you did just type all this into your calculator all at once, that's fine. Also, you should have gotten the same answer. All right, you don't have to write down the what patterns do you notice, but let's talk about it. What did we notice especially about those first 2 problems? Like when we expanded it out. What do you notice there? It's all the same thing, right? Twos, a bunch of twos, a bunch more twos. Okay, so we should notice that we are still just multiplying the same number to itself even more times. That's part of what we're going to talk about today. Here it is, the rule for exponents for products of powers. So remember, any base to an exponent is called a power. Product means we're doing what type of problem? Multiplication. So we are multiplying two powers together. So it says for all positive integers, m and n, a to the m times a to the n is equal to a to the m plus n. The bottom it says to multiply two powers having the same base, that's important, the same base, you must add the exponents together. Multiplying the same base, you add the exponents. All right, on the first one, I'm going to write it out expanded just to show you why that's the case. You might have already noticed it on those warm-ups. If we're taking y to the fourth times y squared, y to the fourth means we have how many y's? 4 of them, and y squared means we have how many y's? 2. So if I write it out expanded, how many y's did I write all together? 6 of them. And what do we notice about 4 and 2? They add up to 6. So that is why we have the product of powers rule that we just talked about. That's why we add the exponents. Okay, so we add 4 plus 2 to get that 6. Number 2 is a little bit different. It's still a multiplication problem. How do I still know that I'm multiplying? The parentheses tell me that. So I'm still going to multiply. Remember, we can multiply in any order. So I could rearrange this to have the 4 times 5 next to each other and to have the n's multiplied next to each other. So there are 2 things we have to do to simplify this. We need to take 4 times 5, which is 20. And we also need to take n cubed times n squared. So that would leave us with n to the 5th power. Okay, we took 3 plus 2 and got 5. So you have to keep it straight when you're multiplying numbers together and when you're adding them together. If they're big coefficients and it's a multiplication problem, you still multiply those 2 numbers together. But when we're multiplying the same base and they both have an exponent, we add the exponents together. Questions about the difference between those 2 scenarios? Okay. On number 3, again, if it helps you to rewrite it, you can. You do not have to. I like rewriting them at first so that I can get used to seeing things together. If I wanted to put an exponent on this x, what would it be? A 1. Okay, we have to keep that in mind, so if you need to write that on there, I would do it. If you're not going to remember it without writing it, make sure you write it. So far, all I did was rearrange the order that it's written in because it's all multiplication. The next thing we need to do is start multiplying pieces together that can go together. -4 times 7 is -28. The x's can get multiplied together if they have the same base. What am I going to do to their exponents? What am I doing to their exponents? adding them. If we multiply the same base, we add the exponents. 2 plus 1 is 3x cubed. Okay, and then on the y's, again, we're multiplying two bases that are the same, y and y. If we multiply the same base, what do we do with the exponents? Add them. So we get y to the 9th power. Notice that I am not multiplying the x and the y together. Why not? Not the same base. This only works if you have the same base. Questions, concerns about that? Okay, I want you to give number 4 a try, and we'll do the answer in just a moment. All right, do we have any volunteers to tell me what they got for number 4? Keon? X was to which power? 5th power, good. And I agree, y would be to the 3rd power. If you need to rewrite it, rearranging them so that the 5 and the 4 are next to each other, the x's are next to each other, the y's are next to each other, that's fine. But you do not have to do that. It's not a requirement. If you just want to like draw little lines between things that you know get multiplied together, you can also do that. Okay. Any questions about these first examples? Okay, we'll keep it going then. This next example is a little bit different. What's different about it? There's an addition sign in it. We've got a plus sign. Okay, so this is not just all multiplication. We have to watch out for those sneaky little addition and subtraction signs changing it for us. Is addition the only thing we're doing here? No, what else is happening? There's still multiplication going on because of those parentheses right next to each other. So what do we do first? Nobody remembers their order of operations. So, okay, I like that. Exponents kind of go first, but is there any way that we can evaluate what b squared is? Can we change b squared? Or a to the 4th if we don't know what a is? No, we can't evaluate our exponents. So I'm glad that we checked that first, but there's no way for us to change a cubed to just be a number because we don't know what a is. So let's move on past exponents. What would come next? Multiplication. Parentheses should come before exponents, but inside any set of parentheses, is there anything to do? Can I do anything with 2ab squared? No. Okay, 2ab squared is just 2ab squared. Okay, so there are parentheses, but what do those parentheses mean to us? Multiplication. Okay, so everything's pointing back to we need to multiply first. Multiplication always comes before addition. So we are going to multiply these two monomials before the plus sign together. And we're going to multiply the two monomials after the plus sign together. And we are going to leave that plus sign in between them for now. Okay, so we've got two multiplication problems happening. For the first one, I'm going to have to take 2 times negative 6, and I would get negative 12. I have to take a times a to the 4th. A to the 5th. We have to remember that the a has an exponent of 1 on it. 1 plus 4 is 5. Finally, we have to take b squared times b squared. Good. B to the 4th. 2 plus 2 is 4. Now we jump over to the other side. What are we going to multiply by this 2? A 1. Okay, if you need to write the 1 in front there to see it, that's fine. 2 times 1 is 2. A squared times a cubed is a to the 5th. And b times b cubed is b to the 4th. Again, we've got an exponent of 1 on that first b. 1 plus 3 is 4. Now, we have to decide if we can actually add these together. Are these like terms? Yes. The variables are the same with the same exponents. A to the 5th, b to the 4th. A to the 5th, b to the 4th. So we're going to take negative 12 plus 2 and get negative 10. Should I change my exponents on my variables? No. If we are combining like terms, the exponents don't change. That's what that note at the bottom says. When adding like terms, only add the coefficients. That means we don't change the exponents. All right. Examples 6 and 7. What are we doing? What operation? Multiplying. It is all multiplication because everything is contained inside of parentheses. Okay, if we were to have addition or subtraction signs in between the parentheses, that would change it. But if it's all inside of parentheses, they're all just getting multiplied. So, again, you do not have to rearrange them. I'm going to rearrange number 6 so that I can see the like pieces that get multiplied together. So I know that I'm going to take 4 times 1/4 times negative 7. All of those coefficients get multiplied together. And I know I'm going to take m cubed times m squared times m. Multiplication's always commutative, so if that's our only operation, we can rearrange it into whatever order we want to multiply. If I take 4 times 1/4, what does that give me? One. Makes me a little sad that not everybody just yelled that out right away. 4 times 1/4 would be 1. If we put the 4 over 1, the 4s would cross cancel. Right? Okay, so 4 times 1/4 is 1. Times negative 7. What is 1 times negative 7? Negative 7. And then we have to deal with our m's. Okay, you can do them one at a time or you could do them all together. What is m cubed times m squared? M to the 5th. M to the 5th times m is m to the 6th. Remember, there's a 1 on any variable that does not have an exponent written there already. Negative 3 times 2 times negative 4, we agree should be 24. Okay, so negative 3 times 2 would be negative 6 times negative 4 is a positive 24. We're okay with that? Okay, I'm going to take that line away. If you want, after you use something up, you could kind of cross it out. We used up the negative 3, the 2, and the negative 4. Next, we'll go on to our x's. We've got x squared times x cubed. That would give me x to what power? The 6th power. How did we come up with 6? Adding what? The exponents. So 2 plus 1 plus 3. 2 plus 1 is 3 plus 3 more gave us that 6. So now we've used up all the x's. The only thing left is the y's. All right, so we're going to have y cubed times y squared times y. That would give me y to the 6th power. How did we get there? Adding 3 plus 2 plus 1 again. Good. So we have exponent of 3 plus 2 is 5, plus 1 more gives us y to the 6th. Done. We used everything up. Questions about examples 6 and 7? Silence. Okay. What is different about 8, 9, and 10? Ellie? We've got a subtraction problem on 8. We've got a subtraction problem on 10. And on number 9 we have an addition problem. They did not put parentheses on number 9, but we still know that multiplication has to come before what? Addition. Okay, so if you want, you can put some parentheses around these instead of the dot. You could put a big set of parentheses around them if that makes you feel better. Okay, that's fine either way. Same thing on number 10. They didn't put in parentheses, but we know that subtraction comes after we do subtraction comes after what? Is there any addition in this problem? No. Subtraction is going to come after we multiply. So again, if you want to put a big set of parentheses around your two multiplication problems to remind you what to do first, you can do that. Okay, I want you to work through these problems. Remember to multiply first, then add or subtract if you can. I don't know if whoever made this made a typo or was just trying to see who was paying attention. Could go either way. But you'll notice on number 8 that we have how many different variables? 2 different variables. Okay, so I'm thinking somebody just wanted to see who was paying attention. But we'll start by multiplying the first 2 parentheses together. So if you want, you can group those together. Tariana, when I take 6 times 2, what do I get? 12. Now the next part, I would have x to the 5th times s squared. Do those have the same base? No. So should I be adding their exponents? Absolutely not. So we just keep them the same. If they do not have the same base, you do not add their exponents together. Only if they have the same base. Drop down that minus sign in the middle. Jaquan, what is 3 times 4 going to give me? 12. Wonderful. And then can I multiply s to the 4th times s cubed? Yes, they have the same base. So Logan, what do I get when I take s to the 4th times s cubed? S to the 7th. Very good. So now we've done our multiplication. We are ready to move to our next operation, which would be subtraction. Can I subtract these? Let's see a thumbs up, thumbs down. Thumbs up if you think I can subtract these. Thumbs down if I cannot. Should be seeing some more thumbs out here. So, thumbs to the side if you got no idea what's going on. Okay, some honest people here. In order to add or subtract, these need to be like terms. For them to be like terms, they need to have the same variables with the same exponents. Are these like terms? No, they are not. Okay, the easiest, quickest way to tell is the fact that the 12x to the 5th s squared has an x in it somewhere, and the other one doesn't have an x in it anywhere. Okay, these are not like terms. They do not match. They don't look the same. They cannot be combined. So that's as far as we can take it. There's nothing else we can do. Now, if in the very beginning of the problem, this x had been an s, the whole problem would have been very different. Okay? Maybe if we get a minute at the end, we'll talk about it. For now, we'll move on to number 9. We already talked about how we need to multiply inside those parentheses we added first. Connie, if I take 5 times 4, what do I get? 20. Nevaeh, if I take x cubed times x squared, what do I get? X cubed times x squared. X to the 5th. Good. We add our exponents. Plus, now we're ready to go on to the other side. Deshaun, if I take 2 times 3, what do I get? 2 times 3? I think I just didn't hear you. 2 times 3. Just this 2 times that 3. 6. Good. All right, and then we have to take x times x to the 4th, Ellie.
Wait, I'm looking at the wrong phone.
I think you said it, x to the 5th? Yep. Okay, so we add 1 plus 4. That's how we get x to the 5th. Are we done with this problem? No, these are like terms, so we can combine them. Delaney, what do we get? X to the... What do we think? 5th power. What did that note say at the bottom on the front? When we combine like terms, we only add the coefficients. If you are combining like terms, your exponents don't change. All right, let's move on to our last one. Again, we talked about how we need to group the multiplication pieces together first, and then after that we will subtract if we can. Danielle, when we take 4 times 2, we get 8. So that takes care of the 4 times 2. May, if I take a squared times a to the 4th, what do I get? A to the 6th. Wonderful. Kelby, if I take b squared times b to the 5th, what do I get? We're taking b squared times b to the 5th. Good. B to the 7th. Drop down that minus sign. Somebody asked the question if this was a negative 3. I would say no. That's a minus sign, so we bring it down. We treat this like it's a positive 3. Okay, just drop that minus sign down. On this one, we technically need to take 3 times a 1 there. 3 times 1 is 3. Okay, that one's an easy one. Jeriel, when I take a times a to the 5th, what do I get? Or right over here, a times a to the 5th. Very good, a to the 6th. And finally, Ryan, we have to take b cubed times b to the 4th.
B to the 7th.
B to the 7th. Wonderful. Then we have to decide, can we combine these? Yes, they both have a to the 6th, b to the 7th. A to the 6th, b to the 7th. If they match perfectly, we can combine them. So we are going to take 8 minus 3. 8 minus 3 is 5. Are my exponents going to change? No. When we combine like terms, exponents do not change. Exponents are only going to change during the multiplying step. Exponents only change during the multiplying step.